All right, so we are going to begin the new unit. You may notice at the top of your slides it says 3.1. We are not doing chapter 2 right now. We're going to do chapter 2 at the end of the year, maybe, depending on how time goes. It just is not integral that we do chapter 2 before we do chapter 3, so I've shifted it so that we can get a little bit further ahead, and then if we don't get to it, we won't get to it, and it's not that big a deal, okay? It's not on your EOC, so it's more like a bonus chapter, so if we have time for it, we'll get to it. If not, no big deal. All right, so we are moving on to lines and angles, which follows pretty naturally from what we started with, which is why the rewind is actually from kind of a long time ago rather than just a couple days ago. So we haven't seen this stuff in a while, but you guys did a fairly good job on your rewind. So remind me of these underlined words that are our vocabulary. These are the important vocab words. Remind me what adjacent means. Right next to, right? So what are my options for adjacent to 2? 1 or 3. Either one of those would have been a fine answer because they're both adjacent to 2. What does vertical angle mean? Across from each other? So like give me one of the pairs. 2 and 4 or 1 and 3. Those angles are what? Vertical angles have to be equal to each other, congruent to each other, okay? Which makes number 4 true or false? True, because angle 1 and 3 are vertical angles, so they have to be congruent to each other. All right, what about number 3? Identify a linear pair. Has to make 180 degrees, and they also have to be on the same line, so adjacent to each other. Exactly. So give me an example of a linear pair. 2 and 3, 1 and 2, 1 and 4, 3 and 4. So there's actually 4 linear pairs here because 3 and 4 make a straight line, 2 and 3 make a straight line, 1 and 4 make a straight line. And straight lines always add up to what? 180. 180 degrees. So the angles add up to 180. Does that mean this line is 180 centimeters long? No. Okay. So a lot of people on their test and quiz wanted to say like, if I add 2 pieces of a line together, it always equals 180. That's not true. Okay. That is only true about angles, not like the actual pieces of the line, because these lines have what on the end of them? Arrows, which means how long are they really? Forever. They're infinite. So you can't say they're 180 long because they go on forever. All right? So remember, 180 is with angles. Okay, so we have a lot of words, a lot of definitions to get through today. Some of them, most of them probably you already know. So there shouldn't be that much that's too new. We're just applying it in a different way. So what are parallel lines? What are parallel lines? I bet not a single one of you, when I said what are parallel lines, would have said, oh, those are coplanar lines that don't ever intersect, right? This is like a fancy geometric definition for 2 lines that never what? Touch. Exactly. Parallel lines are 2 lines that never touch. So Martin in the back went like this. This is what parallel lines do, right? They never touch each other. A lot of times we think about them like railroad tracks because 2 tracks of a railroad won't ever touch. Because if they do, what would happen to the train? Yeah, it would like hit itself, right? So parallel lines are 2 lines that never touch. In other words, coplanar lines that do not intersect. What does coplanar mean? On the same plane. So they have to be on the same plane as each other, all right? So that means something like AE is parallel to BF because they're both on the top plane of that box, all right? So AE is parallel to BF. Which other line is AE parallel to? CG. Why, Micah?
Because like AE kind of shares 2 planes.
Very good. AE is on the top plane and it's also on the side plane. So it's parallel to BF because it doesn't touch BF, but it's also on the side and it doesn't touch CG. So would you say that AE is parallel to DH? No, they never touch, but they're also not in the same plane. They're not coplanar, okay? So you can't say that they're parallel because they're not coplanar. And again, this is only an issue when you're talking about a 3-dimensional object. If you just have like a bunch of lines on one plane, it's pretty easy to tell which ones are parallel, okay? What are perpendicular lines? They do intersect, and they intersect in a very specific way. 90-degree angle, so they intersect and they make basically like a square. All right, so 90-degree angles, perpendicular lines will always form 90-degree angles. So they have to touch each other, and they have to make a right angle. Okay, so for instance, EG is perpendicular to what? HG or GH, however you want to say that. It's also perpendicular to EF, okay, because it makes a 90-degree angle there. So perpendicular lines, you're looking for basically square corners. This symbol right here, these little arrows, that means parallel. These little square boxes mean perpendicular, okay, because they also mean right angles. So wherever you see a right angle, those two lines are perpendicular. All right, skew lines is probably new. You probably don't know or haven't seen the word skew before. Skew means they're not coplanar and they don't ever touch. So basically, two lines that never touch each other and aren't on the same plane. So for instance, GC would be skew to like BD. It's never going to touch that line, okay? It's also not on the same plane. So when I'm looking for skew lines, I always just pick opposite corners. I always just pick like the one down here and then the one over here. So just look for things that don't touch. Skew means they're not going to touch each other ever. All right, and I might write that on here, so just never touch. People forget this one because they haven't seen the word before, so if you're trying to think of a way to remember skew, just think of it like they're just never going to touch each other. Pick the farthest ones away that you can find. What do you think a parallel plane is? Yeah, they never touch. They run like, yeah, so just like a parallel line, except we're talking about the whole plane. So how do we name a plane again? If we don't have the cursive letters, how many points do you need? Three. So which plane is the top of a box parallel to? The top of a box would be parallel to the bottom. The right side would be parallel to the left side. Just flip that, but you know what I mean. And then the front would be parallel to the back. So just pick one and name it. So let's pick the front. The front plane is made up of what four letters? E, F, G, H. So just pick three of them. Give me three letters. E, F, G. All right, so E, F, G is parallel to A, B, C. I agree, A, B, C or A, B, D. All right, because the back of the box is A, B, D, C. A, B, C, D. So A, B, C. All right, so those are parallel planes. Again, how do you tell the difference between planes and lines if you're just looking at the letters? Lines should have how many? Two letters. Planes should have three. Okay? A plane, you need 3 points. A line, you need 2. And that's why you need 3 for a plane. Because if I only use 2 letters, you would think I was talking about a line. Okay? But the word parallel means exactly the same thing. They never touch each other. So I always think about it like a shoebox. The top of a shoebox will never touch the bottom of a shoebox. All right? But the side touches the top and the bottom. So pick 2 things that aren't going to touch. Okay, so in this figure below, let's identify each of the following. Give me a pair of parallel segments. Somebody give me one segment on here. Name a segment, any segment. CB. Okay, so give me something that's parallel then to CB. DE, very good. CB is parallel to DE. This symbol right here that looks kind of like the number 11, that means parallel. All right, why do you think that means parallel? Because it's 2 parallel lines. All right, so that symbol means parallel. CB is parallel to DE. CB, bless you. CB is also parallel, bless you. CB is also parallel to what? GF, very good. All right, is CB parallel to JH? Is CB parallel to JH? Why not? They're not on the same plane, which means that they are then what type of segments? Skew. Very good. So we could say CB is skew to JH. We have no symbol for skew. All right, so just CB is skew to JH. They're not touching, but they also are not on the same plane. All right, pick a different segment for me. Pick a different segment. CB, I think we picked already. CD, okay, CD. All right, CD is perpendicular to what? CD is perpendicular to what? ED, good. So CD and ED are perpendicular to each other. The symbol that we use for perpendicular is like an upside down T. CD and DE. CD is also perpendicular to what? CD is also perpendicular to CB. And CB is also perpendicular to CG. Very good. All right. Does anyone notice anything about perpendicular segments compared to parallel ones, like the letters?
They repeat.
In a perpendicular segment, one of them has to repeat because it has to share a vertex. C, if you're going to say CD, then the other ones that it's perpendicular to should also have the letter C in it. Okay? Or D, I guess, since we have D. All right, and then this is meant to say planes. Sorry. Yeah, we already did that one. All right, so give me a pair of parallel planes. Give me one plane. Name a plane. CFJ. CFJ would not be a plane. CFG. Okay, CFG would be a plane. What side of the box is that? Left side of the box. So CFG. That's fine. I was about to say right also. So CFG is the left side of the box, which means it's parallel to what? What side of the box? The right side. So name the right side of the box. If this is the left side, the right side is over here. DHJ, how else could you name it? EHJ, any of those three letters. So I'm going to pick DHJ because it doesn't matter at all. Just pick three of the letters. If you pick four of the letters, I'm not going to mark you wrong. All right, so if you're ever like, I can't remember, do I pick 3 or 4? Err on the side of more. All right? Telling me more information about a plane is better than telling me less. Because again, if you pick 2, I'm going to think it's a line. Good. Okay, before you go up, hang on. I'm going to pick segments here so that there's only one right answer rather than 8 right answers. So give me a second. So one pair of perpendicular segments, I basically just want you to fill in the blanks here, okay? So I want something that's perpendicular to BC. For one pair of skew segments, I want something that's skew to AE. For one pair of parallel segments, something parallel to CG. And then one pair of parallel planes, I want something parallel to plane A, B, C. Okay, go try these 4. Okay, so the other definitions and groups that we're going to talk about today, I am putting this slide up here so that you have it to refer back to. I'm not going to read through all of it because honestly I think this is easier to conceptualize if you just look at a picture of it because this is a lot of words. But these are the 5 things that we're going to go through right now. And the most important one is transversal. So in this picture, we have a set of 2 parallel lines and they have a line cutting through them. The line that cuts through 2 parallel lines is called a transversal. Okay, so if this is line A, line B, and line C, which of those is the transversal? C is the transversal. So a transversal cuts through two or more parallel lines, but typically we're just working with 2. All right? So a transversal is the line that cuts through 2 or more parallel lines. As you can see, it creates how many angles? A lot. How many? 8. It makes 8 because at every intersection, how many angles are there? 4. So there's 4 on top and 4 on the bottom. Okay? So when the transversal C cuts through line A, it makes 4 angles. And when it cuts through line B, it makes 4 angles. So again, the example here of a transversal would be line C. All right, line C is the one that cuts through it. A and B would be the what? Parallel lines, exactly. And you know those are parallel because they don't touch. Good. Okay, so when it cuts through these, it makes 4 different types of angle relationships. All right? Now there's some words in here that are going to help you figure out what angle relationships we're talking about. But before we do that, I want to make some definitions. So what does alternate mean? If you have like, yeah. Like the other version, right? Okay, so all right, good. So alternate would be like on the alternate side would be like opposite sides, kind of. Yeah, it kind of means the same thing as opposite. What does interior mean? Inside, good. What does exterior mean? Outside. And then same side means on the same side. Okay, so when you're looking at these, the way that I like to describe it sometimes is like your parallel lines are like 2 pieces of bread, all right? And all the stuff, like all the meat of your sandwich, those are your interior angles. So which are your interior angles here? 4, 3, 5, and 6. So which are your exterior angles? 1, 2, 8, and 7. Because they're outside the bread, all right? They're not on your sandwich. So they're not inside it. They're not in the interior. So here are your interior angles. And here are your exteriors up here. And then some more exteriors down here. All right, so we're going to go through these bottom 3 first, and then we'll do corresponding at the end. Okay, so alternate interior angles are angles that are inside the sandwich, but on opposite sides of the transversal. So for example, 4 would be alternate interior to 6, okay? Because 4 is on the left side and 6 is on the right side, but they're both inside the parallel lines.
Would it also be alternate to 3?
No, because 4 and 3 are adjacent angles. Okay, so 4 and 3 are adjacent to each other. Alternate is opposite, so they have to be on the opposite sides, but both inside, they can't be adjacent. So we would say 4 and 6. Yes, Madeline. It could also be 3 and 5. Very good. So the other set would be 3 and angle 5. All right, so those are my alternate interior. And again, alternate means opposite, so they cannot be adjacent to each other. All right, so then knowing that, what do you think my alternate exterior angles might be? 1 and 7. And angle 2 and 8. And how do you know that? Good. 1 is on which side? The left, so then the 7 would be the alternate exterior to that. And 2 is on the right, so the 8 would be the alternate exterior to that. And we're talking exterior because they're outside the sandwich. All right? Same side interior. 3 and 6 and 4 and 5. Good. How do you know that? Good. So angle 3 and 6 are on the same side, but they're inside the sandwich. And angle 4 and 5 are also on the same side, but inside the sandwich. Okay. Corresponding. What does it mean for things to be corresponding? Martin? It would be like angle 1 and 5. Yes, good. Okay, so corresponding angles, I want you to take a look here at just the top 4. What position is angle 1 in? It's in the top left corner, right? Which one is in the top left corner down here? 5. So that's why 1 and 5 are corresponding. Corresponding means in the same position as. So what Martin said is right. One's interior, one's exterior, but they're basically in this set of 4 and this set of 4, they're in the same spot. So 1 corresponds to 5. 2 then would correspond to 6. 4 corresponds to 8, and 3 corresponds to 7. All right, so we have 4 examples here. So it was 1 and 5, 2 and 6, 3 and 7, and 4 and 8. All right, so corresponding will always be, there will be more of those than there are of the others, because again, how many angles does this make? 4, and each one corresponds to another one in the next set. All right, so if you think about it like the top set and the bottom set, 3 is in the bottom right, so then 7 is in the bottom right of the other set. Corresponding, for some reason, I think because these are basically, they tell you exactly what it means. As long as you remember the definition of the words for these 3, it tells you exactly what it means. Corresponding requires that you remember what corresponding means. Okay, corresponding means in the same position as. Now, again, we're not doing this just to learn the vocab. We're doing this because there's things that are true about all of these. Corresponding angles, alternate interior angles, and alternate exterior angles are all, what's this symbol? Congruent, which means that they are the same. So if this is 60, if 1 is 60, what's 5? 60. If 2 is 120, what's 6? 120. Okay, same side interiors, the only ones that are different, they are not congruent, they are supplementary. Which means that they do what? Add up to 180. All right, so same side interiors add up to 180. That seems like a lot to memorize, but bear with me. I want you guys to think about this like, which one is bigger, angle 1 or 2? Angle 1 or 2, which one is bigger? No, they're not the same. Visually, it looks like 1 is bigger. All the other bigger angles on here are going to be the same as angle 1. So if this is 120, this one's also 120, this one's also 120, and this one's also 120. Okay? There's only ever going to be 2 measurements. If one of them's 120, what would the other one be? 60, because they have to add up to 180. All right, so we're going to use that in practice a lot this year. But this seems like a lot to memorize, but just understand that most of them are congruent. The only ones that aren't are these same side interiors. And same side interiors add up to what? 180. Pretty much with angles, they're either going to be equal or they're going to add up to 180. That's, if you have to guess one or the other, go with one of those things. Okay, give an example of, I'm going to do this again. All right, which one corresponds to 2? Which one corresponds to 2? 6, why? It's in the same position. 2 is on the top right, 6 is on the top right. Which one is alternate interior to 2? Oh, sorry, 3. 5, very good. So angle 5. Which one is alternate exterior to 7? 1, because it's opposite and also outside. And then which one is same side interior to 5? 4. Good. All right. Okay. What's happening here? What's happening here? Yeah, they're not parallel, right? So here they aren't parallel, but we still consider a transversal to be the one that cuts through it. So let's say I'm looking for angles 1 and 5. Here's angle 1. Here's angle 5. Which would be the transversal that cuts through both of those? Which, and again, transversal should be a line, right? So it's either going to be L, M, or N. Which is the transversal for 1 and 5? N. Why is it N? N touches both of them, right? So this one would have to be N. Okay, now, are they inside or outside of the other two lines? Inside? Are they on the same side or alternate sides of the... So these would be alternate interior because they are in between the other two lines, but on different sides. So I'm going to say that as alternate interior angles. AIA. All right, 3 and 6. What's the transversal for 3 and 6? M. Why, Micah?
Because
It's the line that touches both of them. So M. Okay. And then, what are my other two lines? L and N. So are 3 and 6 inside, or is one inside, one outside? One inside and one is outside. So if one's inside and one's outside, then they have to be... Nope, because that would be if they're both outside. Corresponding. That's the other way you can tell if things are corresponding, because one's inside, one's outside. They can't be interiors or exteriors at that point because you have one of each. So if you think about it like this, in this set, this is on the bottom left, right? In this set of 4. And then in this set of 4, this one's also on the bottom left side. Okay, so corresponding, again, means same position. Micah?
How is 6 not on the inside?
Because the other two lines are L and N, and it's not in between those two lines.
Oh.
Good question. Yes, I did not explain that right. So because this is like your bread now, 6 would be outside of your sandwich. What's the other one that's inside it? 5. So 5 is interior, 6 would be outside because here's your other line. And then the third line is always the transversal because it's the one that touches both of them. Never can get it to work. All right, 1 and 4. So what's my transversal? L. So then my other two lines are M and N. So my sandwich bread is M and N. So are 1 and 4 interior, exterior, or one of each? Exterior. Are they on the same side or different sides of L? Different sides. So we would call these alternate exterior angles. All right? Alternate exterior angles. When I do these problems, I always highlight the lines, because otherwise it's really hard for me to visualize. It's very easy if they're parallel, or maybe easy is not the right word, but it's way simpler if they're parallel. When they throw them at you and they're not parallel, I think that makes it a lot more difficult. So I always just highlight the lines. And if that means I draw it 3 different times, then I draw it 3 different times. Okay, so I would like you to skip 6, 7, 8, and 9 and do 10 and 11, just 10 and 11. Okay, what we just did for 10 and 11. So give me the transversal and then tell me what kind of pair it is. So classify it, do the transversal and classify.